Hi, we're going to be reading the book called Curious About Snow today. So, a little bit about snow now. This isn't an actual background of the Minnesota landscape right now. We don't have any more snow because it melted. So, I know, I was hoping to read this book outside to you, but we don't have any snow here. It's almost the end of November, so hopefully we get some soon so I can observe some beautiful snowflakes. So, some fun facts about snowflakes or how to investigate them further or up close. My recommendation to you is to find a dark colored piece of paper, maybe a clipboard, a folder, something that has a solid background of black or a really dark color. So set this item outside, keep it cold, maybe put it in your garage so it's cold the next time you want to go outside and investigate the snowflakes falling from the sky that will land on your object. So then, for instance, if I was using this book and a snowflake fell, it wouldn't melt right away because this object is already cold. See, when snowflakes land on you, they're going to most likely melt right away because your body heat will warm them up and cause them to melt. So that's why it's really important to have a cold, dark object for the snowflakes to land on. And hopefully the snowfall is gentle enough where the snowflakes don't break, where they don't break apart and form clusters or big clumps of snow coming down. Hopefully it's just the perfect snowfall, and then all the snowflakes will remain intact once they hit your cold surface. You can even bring like a magnifying glass to help you see all the intricate details of every individual and unique snowflake. So we better read this book. So this is Curious About Snow by Gina. And you can follow along with me with your book or just listen. Have you ever built a snow fort or tossed snowballs or caught a snowflake on your tongue or wished you could try this where you lived? Snow often makes people stop what they're doing to watch it fall from the sky. But what is snow and how is it formed? To snow, the temperature must be below 32 degrees Fahrenheit or 0 degrees Celsius, the freezing point of water. Water vapor, a gas that is produced when water evaporates, sticks to a cold speck inside a cloud and makes it wet. This speck can be a particle of soil or salt left over from ocean water that evaporated. Ocean water doesn't necessarily get all the way over to Minnesota. So when our snowflakes or raindrops fall, it will be little drops or specks of dirt, actually. That's what the water can attach to, and then when the snowflake freezes, it branches out 6 different branches because a water molecule has 6 bonds. So when those freeze, it will take shape of a, what's that 6-sided figure am I talking about? The hexagon. It's going to turn into a hexagonal shape. And in the middle of the snowflake, which is kind of cool, you probably never knew this, is a small microscopic, or maybe you can see it, speck of soil or particle of like debris or something. Anywho, it can be pollen from a flower or ash from a volcano, among other things. Inside the cloud, more water vapor sticks to the wet speck and forms a water droplet. This droplet freezes into a ball of ice, and more water vapor sticks to it. Ooh. The ball of ice begins to grow into a hexagon-shaped ice crystal. Water vapor sticks to the crystal's 6 corners first, since they stick out farther than any other part of the crystal. As the 6 corners continue to grow and push outward, they begin to form arms. This process is called branching, kind of like the lovely trees behind me. Branches on the 6 corners begin to sprout. The new branches keep growing and form little arms of their own. Soon, an amazing snow crystal forms. To scientists, snowflakes and snow crystals are the same thing. Branches on the 6 corners begin to sprout. The new branches keep growing and form little arms of their own. So here's our snowflake starting to form. See those water molecules starting to branch out. Cool. All right. Here is our next page. The snow crystal. The snow crystal keeps growing as it falls through the cloud. The size of the snowflake depends on how many ice crystals connect together. An average size snowflake is usually made up of about 200 ice crystals and 180 billion molecules of water. Wow. The shape of the snowflake is determined by the temperature and humidity of the air. The colder the air temperature, the sharper the tips of the snow crystal will be. At warmer temperatures, snow crystals grow slower and their shapes are less sharp. Snow crystals usually form simpler shapes when the humidity is low and more complex shape when the humidity is high. When a snowflake becomes heavy enough, it falls through the cloud to the ground. It continues to grow and change as it falls towards the earth. If the ground is cold enough, the snowflake will stick to it and won't melt right away. This is true. How do we know as much as we do about snowflakes? A man named Wilson A. Bentley loved snow so much he studied it for most of his life. Bentley was born on February 9th, 1865. There's a photograph of him. He grew up and worked on his family farm in Jericho, Vermont, in the heart of the snow belt. The yearly snowfall in Jericho was about 120 inches. It was a perfect place to learn about snow. I could be pronouncing that name wrong. As a young boy, Bentley enjoyed studying the world around him, from butterflies, leaves, and spiderwebs to weather conditions, raindrops, and snowflakes. Bentley loved catching single snowflakes and studying them. Bentley's mother gave him an old microscope for his 15th birthday. Looking at snowflakes through his microscope, he was amazed by the beautiful crystals and by how many different types of snowflakes he found. For 3 winters, Bentley drew 100 snowflakes a year, but the snow crystals always melted before he could finish drawing them. This was very frustrating to him. I wonder what he did. When Bentley turned 17, his parents bought him a bellows camera and a new microscope. He attached the microscope to the camera and spent the next 2 years trying to photograph snowflakes. Snowflakes are very difficult to photograph because they melt so quickly. But finally, on January 15th, 1885, when he was 19 years old, Bentley became the first person ever to photograph a single snowflake. He then went on to capture more than 5,000 images of snow crystals. Here's a really fun book called Snowflake Bentley. And this is a book about him discovering how to take a great photograph of the snowflake. This is a great book. Okay. I'll make a recording of me reading that book as well. So if you want to watch it, I'm sure the video is up if you're watching this video. Anyway, because of his amazing work, he became known as the Snowflake Man and was also often called Snowflake Bentley. Many colleges and universities around the world bought Bentley's snow crystal photographs. He published about 60 articles in magazines and journals. His book, Snow Crystals, was published in 1931, the same year that he died. Snow crystals contained more than 2,400 photographs. Bentley wanted people to be able to study and enjoy his snowflake photographs. His mission was to record something that disappeared very quickly. Wow. Look at some of these snowflakes. There's all sorts of different types. If you go online and do some research, you'll be able to see different types of snowflakes. They're amazing. Okay. Wilson Bentley proved that snowflakes had different shapes, but almost all had 6 sides. Star-shaped snowflakes are called stellar dendrites. They have 6 arms that branch out from a center point. The center point is the speck that started the crystal. These snowflakes form when the temperature is about 5 degrees Fahrenheit or negative 15 degrees Celsius. The shape is one most people think of as a snowflake. So as you can see, it's got those 6 branches, main branches. All right. Speaking of 6, hexagonal plate snowflakes don't have arms. The points are the beginnings of arms that were just starting to develop when the crystal fell out of its cloud and stopped growing. These snowflakes form when the temperature is near 30 or 28 degrees Fahrenheit or near 5 degrees Fahrenheit. Sometimes a star pattern can be seen in the center of a hexagonal plate. Ooh, I like how it gives us specific temperatures of what snowflakes you can see. Modern scientists and photographers have continued Wilson Bentley's work. Their photographs, like his, tell us more about different snowflakes. A stellar plate is a snowflake whose shape fans out like a star. Stellar plates may have bumps or simple arms without branches. They are more common than hexagonal plate snowflakes. Well, the next ones are really crazy looking. Needles are very thin snow crystals. They may be solid, hollow, or partly hollow. They grow when the temperature is about 23 degrees Fahrenheit. Column snow crystals have 6 sides. These crystals can be solid, hollow, or capped. They can be short and squat or long and thin. Column snowflakes, which is this bottom picture here, column snowflakes form very high in the clouds and at very cold temperatures. They are tiny. Snow crystals that fall as columns make for very slippery snow. I wonder why that is. It is highly unlikely that any 2 snowflakes ever look the same. They all form in their own way, even though they start out with the same structure. So much can happen as a snow crystal falls to the earth. For example, if a water droplet passes close to one arm, that arm might grow faster. Soon, that arm will be a lot longer than the others. For this reason, most snowflakes are not perfect. They may grow unevenly, break, melt, and refreeze, or come in contact with other ice crystals. Ooh, these are almost like iridescent. Okay. A snow crystal might be a twin. It can have 12 arms. This happens when two ice crystals start. What? This happens when two ice crystals start from one speck and form on top of each other. So here's our twin snowflake with 12 branches. Some snowflakes have little bumps on them. These bumps are called rime. Sometimes water droplets strike the crystals and freeze on contact. This causes rime. Interesting. Who knew? As pretty as snowflakes can be, snow can be dangerous. Heavy snow can strand drivers, block deliveries, and disrupt emergency services. Buildings can collapse under the weight of too much snow. Trees and power lines can come down. Here are some winter storms to watch out for. A snowstorm is a storm with a large amount of falling snow. Billions of snowflakes fall in every snowstorm. During a thunderstorm, thunder rumbles and lightning flashes. Sometimes as much as 2 inches of snow per hour will fall. And in Minnesota, we know that to be very true. But it's fun to play in anyway. All right. Blizzards are snowstorms that contain large amounts of snow or blowing snow. Winds are usually more than 35 miles an hour. Visibility is less than a quarter mile. A blizzard continues for more than 3 hours. An avalanche, also called a snowslide, is a moving mass of snow that slides down a mountain. It may contain ice, soil, rocks, and uprooted trees. The avalanche moves closer and becomes more powerful as it gets closer to the bottom of the slope. This can cause even the smallest avalanche to be a major disaster. Ooh, and there's a picture of our avalanche. Snowflakes and snowstorms can set records. Here are some snow facts by the numbers. Okay, let's start up here. 1 inch of rain equals about 6 inches of heavy, wet snow, or 12 inches of very light, puffy snow. About 12% of Earth's land surface is covered with snow and ice. The most snow to fall in one day was 6 feet in Silver Lake, Colorado in 1921. The average snowflake measures about ½ inch. You need a magnifying glass to see its shape. Some of the largest snowflakes range from 3 to 4 inches in length. What? According to Guinness World Records, the world's largest snowflake fell in 1887 in Fort Keogh, Montana. This snowflake was 15 inches wide and 8 inches thick. Am I reading this right? Stampede Pass, Washington, is the snowiest place in the United States. It gets about 36 feet of snow a year. The most snowfall over the course of a year was at Mount Rainier, Washington. It snowed 94 feet from February 19th, 1971 through February 19th, 1972. Oh, wow. People around the world celebrate winter and the snow it brings with winter festivals. Look at the sculptures that they've made. Kids like to celebrate too. Wherever there's snow, you'll see somebody rolling and shaping it, or building a snow person, or digging through it to build a snow cave, or whooshing down a hill on a sled, snow tube, snowboard, or skis. What is your favorite snow activity? Snowmobiling. They don't even have it down here. All right, and then the end of our book is the glossary. So there's some different terms here that were covered in our book. So that is the ending of our book called Curious About Snow. Hope you enjoyed it, and go watch the snow next time it comes down from the sky. You might be surprised what you might find. Bye.